Hey, welcome to Jed Foster Maths. In this video, we're going to be talking about the basics of differentiation calculus. In this video, we're going to be discussing the power rule, and we're also going to talk about what is differentiation, where does it come from, who invented it, and how does differentiation calculus apply to today's day and age. So let's begin. What is differentiation? Essentially, it allows you to find the gradient or the rate of change at any given point, and this can apply to any function. So to help visualize this, let's start off with a basic linear function. So we're going to call this, we're going to set the y-intercept to 3, and we're going to call this function y equals, let's just say 2x plus 3. And we know your gradient m is equal to 2. So that just means it's rising by 2 and going across by 1. And essentially this is your gradient. This is pretty easy to find, right? Because it's linear. And to find your gradient, all you have to do, you have to calculate 2 points on your graph. And you know your m is going to be equal to your delta y over delta x. And this is equal to y2 minus y1 over x2 minus x1. And this basically just allows you to find your gradient. Since this is a linear graph, it's very easy. All you have to do is pick 2 points and you can just apply your gradient formula. So I'm assuming you already know this. This is pretty basic stuff. So before you come into this course, I'm assuming you know basic algebra, basic linear functions. And if not, I suggest go learn them before attempting calculus, because that is fundamental to everything we're going to discuss from now. And let's move on to another example. So you saw, to find your gradient on your linear function, it's very easy. All you have to do is apply your gradient formula. But what if we had a function Okay, so let's say you were given a function of y equals 3x squared minus 5x plus 6. Let's say you were given this function, and you were asked to find the rate of change at just any x value, it doesn't matter, just say you're presented with this function. So it's going to look something like this. And you know your y-intercept is going to be 6. And say with this function, because it's not linear, you can't just apply your basic power rule. Sorry, because it's not linear, you can't just apply your basic m formula to find your gradient. Because you have no 2 points on this graph that are going to be exactly equal, it's always going to have a curvature to it, since the nature of the quadratic. And because of this, you can visualize, say if you pull these 2 points, x equals 5 and we'll say x equals 7, you're essentially trying to calculate the rate of change on that point there. And what you'd be doing by applying your basic gradient formula, m equals delta y over delta x, you're going to be finding this, your average rate of change. While this can be accurate somewhat, it's never going to have 100% accuracy, because the graph's always going to have curvature to it, and technically you can't divide or bring it down to 0, like infinitely small. But what if you could? What if you could theoretically divide by 0 to find an infinitely small portion of this graph, also known as the tangent, at any given point? Now, while this is a hard concept to understand, just imagine you have the same graph here, or the point of the graph from x equals 5 to 7. With differentiation, what this form of calculus does is essentially lets you divide by 0, theoretically, but it works every time. So what if you could make this infinitely small? You could keep dividing this up infinitely small. And by doing that, what you're doing is you're finding the gradient of the tangent at any given point, and it's going to have 100% accuracy, unlike taking your average rate of change. So calculus is a completely different dimension to maths, and it unlocks a lot of possibilities of things that you otherwise wouldn't be able to do. So that's what calculus is, and we'll move on to this graph later. But what we first need to do now is, now you know a bit of what differentiation is used for, let's go over some of the rules for differentiation. So, to find your derivative, your most basic rule is going to be your power rule. So if you were presented with function y equals, we're going to call this 3x squared plus 5x. And we'll leave it at that, but let's say you were asked to find the derivative. You can write your derivative as y prime, or you can also write it as dy over dx. There's a lot of different ways to denote it, but they all say the exact same thing. They all mean the same thing. For the sake of this video, we're going to go with dy dx, as this is probably what's going to be most commonly used in differentiation, and we're going to just use this form for now. And let's start off by finding the derivative of the function above, y equals 3x squared plus 5x. So how do you find its derivative? So basically, with this function, this is pretty much as easy as it gets, alright? So to find your derivative, and I encourage you for this part of the video to pause it, to write things down, make sure you have an understanding of each different rule to differentiation. So to find its derivative with the power rule, you're going to be taking the power of the variable x. You can see this is x squared, so the power is going to be 2. You're going to bring the power out front, 2, then you're going to leave the 3, then you're going to have x, and then with the power, what you're going to do, you're going to take 1 from the power, 2 minus 1. And that's the basic power rule, and then we apply the same concept to the 5x. So we're going to do plus 5. We know this x is to the power of 1. So we're going to do 5. So we're going to have 1 times 5. And then we're going to have x, 1 minus 1. Because we're taking 1 from the power. It's always the exact same thing. You multiply by the power, then you take 1 from the power. And when you multiply, bring it out front. Multiply the constant by the power, or the variable, and that's what you're going to do. So, what do we get once we do this? We're going to have our function of dy over dx is going to be equal to 6x, 2 minus 1 is just 1. I'll write 1 up there, you don't need to though. Just for the sake of this video, to help you get a better understanding of what we're doing. Then we're going to do plus 5 times 1 is just 5. We're going to have x to the power of 0. And I hope you know this, but if not, I'll explain it. Anything to the power of 0 is just 1. So we're going to have 5 times 1, which is just 5. And that's the derivative of this function. This is as basic as it gets. So this is your power rule. And what you need to remember with your power rule is you're always going to be multiplying by the power out front, and then you're going to be taking 1 from the power. So now we've looked at the power rule. I'll write it up here as well, in case you want to copy it down or anything. So we're going to have your power rule is equal to multiply by the power and take 1 from the power. This is your power rule. And let's move on to just some general rules for differentiation regarding logarithms, exponentials, trig functions, that kind of stuff. And also, just to keep in mind, I'm teaching you all this. There is another way to differentiation. This is by first principles. We're not going to cover that in this video because like no one really uses it. But that's just the theory behind what we're doing here. And first principles is good to understand. So if you want to have a deeper understanding of where these rules actually come from, then I encourage you just go search up your differentiation by first principles. Watch a video on it if you like having a deeper understanding of these things. But everything we're doing here just comes from your first principles of differentiation. This is just an easier, more efficient way to do it. And this is the way they'll teach you in universities and school. And this is what you'd be doing on your exams as well. Because by first principles can be very tricky to work with some of the like harder derivatives. And it just takes a lot longer in general. So we're going to be doing it this way, but just keep in mind everything that I'm showing you here comes from first principles. And by the way, you're not losing anything from doing the shortcut. You can actually do more, so keep that in mind. Okay, so now we've covered the power rule, we're going to move on to, we're going to have our table of derivatives. And what this means is, say we're given a function like y equals ln x. Going to look something like that. And notice with the ln x, you don't really have any, you don't know how to differentiate it. And that's what we're going to be covering. We're going to be going over derivatives of different functions in maths, alright? So let's say y equals ln of x. So this is your derivative of ln x. And to make it easier, we're going to put this in a table. We're going to have y, then we're going to have dy over dx. And make sure you copy this down or you take a screenshot. Because you're not going to remember all this the first day you're learning differentiation. It takes a while to remember all these. So just use the table, but do try and start learning these so you can remember them off the top of your head, because in exams and situations like that, you don't really want to be looking at formula sheets and wasting time like that. It's always way better to know this stuff. So let's say we have y is ln x. We know that's going to differentiate to 1 on x. So that's the derivative of ln x. So yeah, just make sure you write these down. These are very important to remember. Y equals ln x, dy dx is 1 on x. 1 on x is the derivative of the natural log of x. So that's the first one. Then we're going to move to e to the x. This is the easiest derivative in the books, alright? That's just going to be e to the x. And I'll cover what happens if you have like a power or something in your derivative of e to the x later on, if you have like a 2x or something, but for now we're just going to cover the basics, alright? Let's move on to your trig functions. We're just going to focus on cos of x. Its derivative is negative sine of x, and sine of x, its derivative is just cosine of x. Alright? So these are going to be just your basic differentiation rules. These are what you're going to see most in your questions and exams, so just make sure you have a copy of this table of derivatives, and we're going to build on it later, but we're just going to focus on these for now. So now you know your power rule. Let's work on a few examples. let's say we had y equals 5x squared plus 10x minus 6. And I want you to pause this video, give this a go. It's the best way to learn is by attempting these things yourself. So make sure to pause the video, give it a go, then come back and I'll explain how I did it. So to differentiate this using the power rule, we're going to have dy over dx is going to be equal to, we're multiplying by the power, we're going to have 2 multiplied by 5, x, 2 minus 1, plus, we're going to have 1 times 10, x, 1 minus 1. And yeah, sorry, the other rule for differentiation is any constant goes to 0. So this negative 6 here is just going to be 0, alright? And I'll just write it down just so you know what we're doing. And once you get good at these, you can start doing these in your head, skipping steps. But when you're first doing it, make sure you just write everything down, as it's going to help just set in stone in your mind what you're doing and help you have a broader understanding of differentiation. So we can say that dy over dx is going to be equal to 10x, 2 minus 1 is just 1, and then we're going to have 1 times 10 is just 10, x to the power of 0 is just 1, so that's going to stay as 10, and then we're going to have minus 0, and we're not going to write that, and that's your derivative of y equals 5x squared plus 10x minus 6. And you can just get rid of the 1 and just leave it like that. And yeah, that's the power rule. So let's move on to a different function. Let's say y equals, we're going to have ln of x minus 6x squared. To differentiate this, remember from your table of derivatives, ln x its derivative is just 1 on x. So we're going to have dy over dx equals 1 on x, as that's the derivative of ln x. Then we're going to have minus 2 times 6, 12x, 2 minus 1 to the power of 1. So that's the derivative of y equals ln x minus 6x squared. Let's move on. We'll have y equals cos of x. Actually, let's have y equals the negative cos of x. Let's find its derivative. Dy over dx equals, and from our table of derivatives, cos of x, its derivative is negative sine x. So we're going to have negative sine of x, which is just going to be equal to sine of x. Because the negatives will cancel each other out. Let's move on to an exponential, and I'll cover what we do when we have an expo function that's not just to the power of x, but let's say we were given y equals e to the, we'll have 2x squared plus 6x, and this is all to the power. And when you're differentiating these, I'll explain what the rule is. It's very simple, and you just need to know the process and how to apply it. So let's go over this. So what you're going to do first, we're going to draw in some brackets. It's important to draw brackets in, and I'll explain why in a minute. And we're going to take the derivative of the power. So that's e to the power of 2x squared plus 6x. We're going to be taking the derivative of the power, then multiplying it by the original function, which is not going to change. So what's the derivative of the power? Using our power rule, we know that's going to be 4x plus 6. And then we're just going to be leaving the function as the same. The exponential function is not going to change. We're going to have e 2x squared plus 6x. And that is our derivative. So that's the rule with exponential functions when you have more than just a power in your exponent. When you have a function like this, 2x squared plus So when you have e to the power of something that's not just basically an x or something, when there's a little more to it, just remember what we're doing is we're multiplying the original function by the derivative of the power. So that is the derivative. And we know the power remains the same. So that's your rule to your exponential functions. And that's also why we have e to the x and we have dy dx equals. Because e to the x, the derivative of x is just 1 times e to the x. Because we're just leaving, we're not touching the exponent. It's going to stay the same. So don't mess with that. All we're doing is we're multiplying by the derivative and then keeping the function the same. So that's your rule to your exponents. Let's do one more. So let's say we had y equals e to the... Spice this one up a little bit. We'll have e to the ln of x. So what do we have to do for this one? We're going to have dy over dx equals, and remember from your table of derivatives that the derivative of ln x is 1 on x. Then we're going to leave the function the same times e to the ln of x. And you'd also be able to pick up the e to the ln x is just going to equal x. That was probably not the best example, but just to show you my point. And let's do one more. We're going to have y equals, we'll say e to the cos of x, dy dx equals, we know cos of x differentiates to negative sine x. So we're going to have negative sine of x to the e to the cos of x. So that's the rules regarding exponentials, and I also snuck in there a few other things as well. Just to combine these a little bit. And let's move on to a few more power rule questions. Let's say you had y equals, we'll say we'll have 5x to the power, we'll do 5 to the square root of x plus, then we're going to have 6, let's do 6 over x squared, just to make these get a little more complicated, but remember the rules are still going to be the same. First off, what we're going to do, we're going to write this to make it a bit more simple. So we know that the square root of x is just the same as x to the power of a half. We're going to have 5x to the power of a half. We're going to have, we know that 6, we're going to have 6 times 1 on x squared. Doesn't really matter how you write these, but I'm just trying to show you to make it a bit more simple. And let's move on. We can simplify this down a bit further actually. We're going to have y equals 5x to the half plus, we can bring the x up the top. We're going to have 6x to the negative 2. This is just your basic indices rules. And if you don't know these, just go watch a video on them. Make sure you're up to scratch with your indices rules. That's very important for differentiation. Because there's a lot of easy mistakes to be made there. And now let's move on to differentiating this. So we're going to have dy over dx, our derivative, is going to be a half times 5 times x, and a half take a half is just a negative a half. And there's an easy way to work with fractions. Your calculator will do them for you, but it's good to know how to do this off the top of your head. And for differentiation, because we're just always taking 1 from the power, I'll show you an easy way to do this. We'll have 5, let's just say we had x to the half. We'll just write to the half. And when you're taking 1 from the power, it's just going to be your numerator 1 minus your denominator 2. And then the denominator is going to stay the same. That's just negative a half. So that's just an easy pattern to try and remember. It's just going to be your numerator minus your denominator all on top, then divided by your denominator is going to remain the same. And that's the same for any fraction when you're taking 1 from the power. Okay, so let's move on to the 6x to the negative 2. Then we're going to have plus, we know that's going to be minus 2 times 6x minus 3. And remember, we're taking 1 from the power, so it's going to go to minus 3. It's not going to go to minus 1, it's going to go to minus 3 because we're taking 1. We're always taking 1, it's always going to become more negative, right? And let's simplify this down. Dy dx equals to 5 on 2. We can have 5 divided by 2 to the square root of x. And then we're going to have minus 12 over x cubed. And this is just me simplifying it down a bit. This is right. This is right. Doesn't matter how you write it. If you're not comfortable with simplifying things down, or you don't know all the rules with indices and powers, it's perfectly fine to leave it like this. This is correct. This is also correct. Depending on how harsh the people are who are marking these, if you have any exams, doesn't really matter. They're both right. It's always good to simplify things down a bit though, because we know 5x to the negative half. We bring that down to the denominator, becomes x to the half, which is just the square root of x. So that's where this comes from. And that's the same with this. X to the negative 3, bring down to the denominator, becomes a positive. Alright, let's do one more example. We're going to make this one a bit more tricky, and I'm going to try and really test that you remember all these skills, so make sure to pause the video and give this a go yourself. But let's say we have the function y equals, we're going to have negative 5 cos of x plus, we'll have e to the negative sine of x, and we're going to have minus 10 times ln x plus 6x squared. So let's say you were given this function and you were asked to differentiate it. Let's work through this. Just pause the video, give this a go yourself, see how you go. So let's start. We'll start by writing dy over dx equals negative 5 cosine of x is going to become 5 sine of x. We're going to have plus e to the negative sine x is going to be plus minus cosine of e to the negative sine of x. Then minus 10 ln x, that's going to be minus 10 times 1 on x plus 12x. I can probably simplify this down a bit. Let's start by writing dy dx 5 sine of x minus cosine e minus sine of x minus 10 on x plus 12x. You could probably mess around with this, try and simplify it down a bit more if you want to, but we'll just leave it like that. And if you got this one correct, well done. If you didn't, go back, rewind the video. Definitely make sure you can do this before moving on to the next video. And thank you so much for watching. If you have any questions, send me a message, leave it in the comments below. I really want to help you out wherever I can. And always remember, Jesus loves you and I love you too. Have a great day. Bye.